మళ్ళీ స్టార్టింగ్ నుంచి. Okay, uh, from second unit, in exam point of view, they may ask projection of points for 7 marks question or 8 marks question. So coming to projection of lines are also two types. One is projection of lines in simple position and line inclined to both planes. This line inclined to both planes, they may ask for 15 marks, and projection of lines in simple position for 7 marks. Either combination of these two they may ask. So either projection of points or projection of lines in simple position. Okay, next, projection of planes also 15 marks question. This is we are having different types of planes like pentagonal plane, hexagonal plane, circular plane. This position of projection of planes they may ask in inclined to both planes, that is oblique planes. So these are the expected questions from second unit. So either combination of points or lines or planes for 15 marks, lines and points may come from 8 marks and 7 marks. Next one, projection of solids. Projection of solids are also comes from 15 marks. They may ask projection of solid inclined to both planes. Okay, and sections of solids also for 15 marks. In that they are asking front view, top view, sectional view, side view, true shape of the section. So this is very lengthy problem and easy problem. Okay, these are the expected questions in third unit. And fourth unit and fifth unit, from fourth unit, development of surfaces is easy topic, and in fifth unit, isometric to orthographic. In exam point of view, they are giving 3D picture, and we have to analyze that picture and we need to draw in 2D. So conversion of isometric to orthographic, conversion of 3D to 2D. So these are the topics that are there in our syllabus. Now first we will start scales. In that unit conversation, scales, this is very important concept in drawing. So basically we have three types of scales. One is plane scale, second one is diagonal scale, third one is vernier scale. Okay, this plane scale measures up to 1 decimal. Okay, plane scale measures up to 1 decimal. Means, for example, plane scale measures only 1.1 meter only. What is mean by 1.1 meter? 1.1 meter means 1 meter and 10 centimeter. So plane scale measures only up to 1 decimal. Okay, this is the function of plane scale. Now coming to diagonal scale and vernier scale, the function of diagonal scale and vernier scale both are same, except construction is different. So this diagonal scale and vernier scale measures up to 2 decimals, This means 1.12 meter. So what is mean by 1.12 meter? Here is 1 meter plus 10 centimeter plus 2 millimeter. So here we are having 3 different units. So plane scale measures only 1 decimal, diagonal scale measures up to 2 decimals. Okay, Now we will see unit conversations. Unit conversations are very important before constructing any scale. So unit conversation. First one is, we all know that 1 centimeter is equal to 10 millimeter and 10 centimeter is equal to 1 decimeter. 10 decimeter is equal to 1 meter and 10 meters is equal to 1 decameter. dm means decimeter, dam means decameter, and 10 decameter is equal to 1 hectometer. 1 hectometer is equal to 10 hectometer is equal to 1 kilometer. This unit conversations are very important before going to construct of any type of scale, either plane, either diagonal or vernier. So 10 mm is equal to 1 centimeter, 10 centimeter is equal to 1 decimeter, 10 decimeter is equal to 1 meter, 10 meter is equal to 1 decameter, and 10 decameter is equal to 1 hectometer, 10 hectometer is equal to 1 kilometer. So before constructing any scales, we should remember all these unit conversations. Next, steps. Steps involved in construction of any scale. These are the steps involved in construction of any scale. First one is recognizing maximum distance that is given in the problem. Recognizing maximum distance given in the problem. And next one is LOS, that is next one is representative factor. That is RF. Okay, first one is recognizing maximum distance that is given in the problem. Next one is representative factor, and next one is LOS, that is length of scale, and last one is construction. So for any type of scale, these 4 steps are common. First, recognizing maximum distance given in the problem. Next one, representative factor. Third one is length of scale, and fourth one is construction. Now first, what is representative factor? Representative factor is, it is represented by the RF, and it is the ratio of length of the drawing divided by actual size of the object. Length of the drawing by actual size of the object. Length of the drawing means whatever we are drawing on the drawing sheet, that is as per dimensions, and this is ideal dimensions, actual size of the object. And if RF value is equal to 1, the ratio of length of drawing and actual size of the object is equal to 1, it is known as 1:1 scale. If RF value is less than 1, it is known as 1:10 or 1:100, like that. So this type of scale is known as reducing scale. So here we are reducing the actual size of the object. We are not drawing as per dimensions. We are reducing the drawing. And last one is enlarging scale, that is RF is greater than 1. If RF value is greater than 1, that is 100 is 10 is to 1 or 100 is to 1, etc. This type of scale is known as enlarging scale. So if RF value is equal to 1, it is actual scale. RF is less than 1, reducing scale. RF is greater than 1, enlarging scale. So RF means representative factor. It is the ratio of length of the drawing by actual size of the object. And next one is length of scale, LOS. And formula of LOS is RF into maximum distance given in the problem. This is the formula. Length of scale is representative factor into maximum distance given in the problem. So all these things we should know before constructing any scale. Recognizing the maximum distance given in the problem. Next one, representative factor. Next one, length of scale, calculation of length of scale, and finally construction. Okay. Now first we will see one example problem. See the problem. This is the problem. So construct a scale of RF is equal to 1 by 60. Here in this problem, representative factor is given, that is RF is equal to 1 by 60 to read yards and feet and long enough to measure up to 5 yards. So this is the problem. So first read the problem, try to understand the problem, analyze the problem and draw the problem. Okay. See, first find out what are the given data. Construct a scale of representative factor RF is equal to 1 by 60 to read yards and feet and long enough to measure up to 5 yards. In this problem, they have given representative factor RF and maximum distance given in the problem also given. Given data, representative factor is 1 by 60 and maximum distance is equal to 5 yards. So first this type of scale is plane. First we need to calculate length of scale. So we know that length of scale LOS is equal to RF into maximum distance. So RF value is 1 by 60 here and length of the scale is maximum distance is 5 yards. So we have to convert this yards into feet. 1 yard is equal to 12 feet and 1 feet is equal to 1 yard is equal to 12 feet. 1 feet is equal to 12 inches. 1 inch is equal to 1 yard is equal to 3 feet. 1 feet is equal to 12 inches and 1 inch is equal to 2.54 centimeter. Okay. First we have to convert yards into centimeters. 5 yards, 1 yard is equal to 3 feet. 1 feet is equal to 12 inches. 1 inch is equal to 2.54 centimeter. Now length of scale is 7.54 centimeter. Like here we have reduced 5 yards into 7.54 centimeter. Now construction. How to construct a plane scale? Our final step is construction. So first you have to draw 7.54 centimeter straight line, and then divide this straight line into 5 equal parts. Here why 5 we are dividing? Because maximum distance given in the problem is 5 yards. So we know that 1 yard is equal to 12. 1 yard is equal to 3 feet. 1 feet is equal to 12 inches. 1 inch is equal to 2.54 centimeter. Okay, and here our length of scale is 7.54 centimeter. So initially we have drawn 7.54 centimeter, and after this we have to divide this 1.54 into 5 equal parts by using acute angle method. You already know what is mean by acute angle method. So acute angle method is used to divide the line into number of equal parts. Here our length of the scale is 7.54 centimeter. We need to divide this 7.54 into 5 equal parts. So by using acute angle method we can divide the line into 5 equal parts. And then next, this line AB is equal to 7.54 centimeter. Next, A as center, you draw 30-degree angle of length is equal to 5 centimeter. This angle should be 30 degrees, and this one I am giving name as A dash. Now divide this A dash into 5 equal parts. So what is the distance between AB? AB is 7.54 centimeter, that is length of scale, and parallel to A dash B, 4 as center, you draw a line which is parallel to A dash B, and then 3 as center, you draw a line with the help of drafter, which is this line is also parallel to A dash B, and similarly 2 center, with the help of drafter you draw another parallel line, and 1 center, with the help of drafter you draw another parallel line. Okay, this line should be parallel to this one. This line also should be parallel to this one. This line also should be parallel to this one. This is also should be parallel to this one. So all these lines are, all blue lines, all white lines are construction lines. This line should not be thick. Here our aim is to construct a plane scale. So except plane scale, remaining all are thin lines only. Next, A center, I am drawing one vertical line. That line should be 5 to 10 mm. Okay, like this I have constructed a rectangle. So next, this point as center, you draw one vertical line. Similarly, this point as center, draw vertical line. This point as center, draw vertical line. This point as center, draw vertical line. So Next, here total 5 boxes are there. Each box here represents 1 yard. This is 1, 2, 3, 4, 5. Total 5 boxes are there. So each box represents 1 yard. That one you need to represent over here. This is yard. 1 yard is equal to 1 box. Similarly, this first box. Here first box, you need to divide this first box into 3 divisions, because here each division represents 1 feet. Yard subunit is feet. So here each box represents 1 yard. Here each division represents 1 feet, and give names as 4, 3, 2, 1, 0. Okay. Now we have to represent we have to mark some 2.2 yards on this scale. What is mean by 2.2 yards? 2.2 yards means 2 yard and 2 feet. So how to represent 2.2 yards in this scale? This is 3, this is 2, this is 1, and this is 0. These are the subscale units, and these are the main scale units. Now 2.2 yard means 2 yards, 2 feet. 2.2 yard. For example, 3.1 yard means 3 yards, 1 feet. 3.1 yard, like this. This is the plane scale problem. Coming to another problem. Construct a scale of 1.5 centimeter is equal to 1 decimeter, and to read up to 1 meter, and show on it a length of 0.6 meter. So first, this problem is also related to plane scale. So here 1.5 centimeter is equal to 1 decimeter. Actual length of the scale is 1 decimeter. That 1 decimeter we are reducing it to 1.5 centimeter on drawing sheet. That scale measures up to 1 meter and show on it a length of 0.6 meter. Given data. So maximum distance is equal to 1 meter, and RF is, we know that RF is ratio of length of the drawing by actual size of the object. Here length of the drawing is 1.5 centimeter and actual size of the object is 1 decimeter. So we have to convert 1 decimeter into centimeter. 1.5 centimeter divided by 1 into 10 centimeter. Here centimeter will get cancelled, and RF is equal to 1.5 divided by 10. RF is 0.15. So this is less than 1. So this means this is also reducing scale only. We are reducing the actual size into next one. Length of scale LOS. Length of scale is equal to RF into maximum distance. So RF is 0.15 into maximum distance is 1 meter. 1 meter is equal to 10 decimeter. 10 decimeter is equal to 10 centimeter. 1 decimeter is equal to 10 centimeter. So this is equal to 0.15 into 100. So length of scale is 15 centimeter. LOS is 15 centimeter. So actual length of the scale is 1 meter, and this 1 meter we are reduced to 15 centimeter. Now construction. This is first step, recognizing the maximum distance. Second one, find out RF. Third one, length of scale, construction of length of scale. And fourth one, construction. First, length of scale is 15 centimeter. Draw 15 centimeter straight line and make this straight line into rectangle. Divide this rectangle into 10 equal parts using acute angle method. This is AB. AB is equal to 15 centimeter. Divide this AB into 10 equal parts. 1, 2, 3, 4, 5, 6. Seven, 8, 9, and 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So here total 10 boxes are there. Each box measures decimeter, and this first box you divide this one into 10 equal parts. Here each division represents 1 centimeter. Okay, this total scale measures 1 meter. Here each division measures, each box measures 1 decimeter. Total length is 1 meter. Here each division measures 1 centimeter. So So we have to represent 0.6 decimeter on this scale. 0.6 means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 0.6 means this is 0.6 decimeter, like this. So this is the problem. Now we will see another problem in diagonal scale. So this is the problem. On a map, the distance between 2 points is 14 centimeter. The real distance between them is 20 kilometer. Draw a diagonal scale of this map to read kilometers, hectometers, and to measure up to 25 kilometers. Show a distance of 17.6 kilometer on this scale. So given data, the distance between 2 points is 14 centimeter and the real distance between them is 20 kilometers. Draw a diagonal scale of this map and to read kilometers, hectometers, and to measure up to 25 kilometers. So maximum distance of the problem is given, that is 25 kilometers. Maximum distance is 25 kilometer. Length of the drawing is 14 centimeter and actual size of the object is 20 kilometers. So we have to mark 17.6 kilometer on the scale. So 17.6 kilometer means 17.6 kilometer means 17.6 is equal to 17 kilometers and 6 hectometers. Okay. First, problems on diagonal scale. First problem, diagonal problem. First problem, that is given data. The distance between 2 points is 14 centimeter. Length of the drawing is 14 centimeter divided by real distance between them is 20 kilometer. This is the length of the drawing. So we know that RF is length of the drawing by actual size of the object. Actual size of the object is 20 kilometers. So first we need to calculate this RF. This is also reducing scale only. 14 divided by 20 into 1000. First I am converting this kilometer into meters. Meters into centimeter. So 1 kilometer is equal to 1000 meters and 1 meter is equal to 100 centimeters. Fourteen divided by 20 into 1000 into 100. 14 divided by 20 into 1000 into 100. This is 7 into 10 power minus 6 centimeter. RF value is this much, 7 into 10 point minus 10 7 into 10 power minus 6. So this is RF value. Next one is length of scale. LOS, length of scale is equal to RF into maximum distance given in the problem. So maximum distance is 25 kilometers. So RF is 7 into 10 power minus 6 into maximum distance given in the problem is 25 kilometers. So 25 into 1000 meters into 100 centimeters. So how much? 7 into 10 power minus 6 into 25 into 1000 into 100. So length of the scale is 17.5 centimeter. So total 25 kilometers we have reduced on drawing sheet as 17.5 centimeter. So total distance is 25 kilometers that we have reduced to 17.5 centimeter on drawing sheet. So construction of scale is different, remaining all steps are same as of plane scale. Recognizing the maximum distance in the problem, find out RF, calculation of length of scale, and these three steps are common except construction. Now we will see the construction of diagonal scale. So 17.5 straight, first we have to draw a rectangle of 17.5 centimeter. This is 17.5 centimeter and this is 50 mm or 5 centimeter. First you draw a rectangle. This length should be equal to 50 mm or 5 centimeter and this length should be equal to 17.5 centimeter. Now you have to divide this box into 5 equal parts. Okay, using acute angle method. Using acute angle method, divide this box into 5 equal parts. 1, 2, 3, 4 and 5. 1, 2, 3, 4, 5. Okay. Here each rectangle box measures 5 kilometers. So 5 into 5, 25. Maximum distance is 25 kilometers. We have drawn 25 kilometers into 17.5 centimeters. We have reduced and we have drawn 17.5 centimeter straight line and we have divided this into 5 equal parts. Each box measures 5 kilometers. Okay. 0, 5, 10, 0, 5, 10, 15, 20. Next, here each box measures 5 kilometer. And next, you divide this first box into, initially you divide this first box into 10 parts like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you divide this part also 10 equal parts: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you give names as A, B, C, D, E, F, G, H, I, J. Similarly, here also you give names as A, B, C, D, E, F, G, H, I. Now you join 0 and A like this diagonally: 0, A, 0, A, B, like this diagonally you join 0, A, B, B, C, C, D, D, E, E, F, F, G, G, H, H, I, finally I, J, like this diagonally you join. Next, divide this portion also into 10 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. You divide this box into 10 equal parts. So here each division measures 1 kilometer, and here each division measures 1 hectometer. Okay, now 17.5 kilometer, how to represent on diagonal scale. So 17.6 we need to represent on this scale. 17 means, as per this scale, 15 plus 2 plus 6. So 15 centimeter, 2 kilometer and 6 hectometer. So first, here 2 divisions is equal to 1 kilometer. 15, and give notations here: 1, 3, 5, 7, 9. Here also 2, 4, 6, 8, like this. So 15 plus 2 plus 6. 15 plus 2 plus 6. This is 2 and this is 6 and this is 15. So this is the representation of 17.6 kilometer. 17.6 kilometer. 17.6 kilometer. So this is about diagonal scale. And next we will see conic sections. Conic sections also very important topic in first unit. We may expect 15 marks questions in this topic. So construction of ellipse, parabola, hyperbola in general methods. So we all know that ellipse, parabola, hyperbola are conic sections because these are appears on the surface of the cone when you cut this cone in particular orientation. So first, before going to draw conic sections, we need to know what are the parts of the cone. Nomenclature of the cone. So this is the axis. Axis is the imaginary line. This point is known as vertex or apex. This point is known as base, and this is axis, and all these are generators. Generators are the not edges, these are the imaginary lines. All these are known as generators. Okay, how cone will generate? We all know that when right angle triangle is rotating about its own axis, it will generate cone. Similarly, if you rotate any two-dimensional rectangle about its own axis, it will generate cylinder. So when a right angle triangle is rotating about its own axis, it will generate cone. When a rectangle plane two-dimensional rectangle rotating about its own axis, it will generate cylinder. So this is the nomenclature of cone: vertex or apex, base, central axis, and generators. These are the nomenclature of cone. So first, this is cone and this is axis. See, if section plane is cutting this cone like this, which is perpendicular to the axis. If I cut the cone like this, section plane is cutting the cone which is perpendicular to the axis. Your top view will appear as a circle. If the section plane is cutting, or cutting plane cuts the cone which is perpendicular to the axis, top view of the cone becomes circle. If the section plane is cutting perpendicular to the axis of the cone, top view will appear as a circle. Similarly, when the section plane is cutting inclined to the axis, section plane is cutting, section or cutting plane section plane is cutting inclined to the axis. So, our top view will appear as a ellipse like this. Your top view will appear as a ellipse. Like this. Okay. Next, if the cutting plane is cutting inclined to axis or parallel to any one of the generator like this. If the section plane is cutting inclined to axis and parallel to any one of the generator, your sectional view will appear as a parabola. If the section plane is cutting inclined to axis or parallel to any one of the generator, our sectional view will be parabola. Okay. This will appear as like this. Cone will appear as like this. Similarly, if the section plane is cutting inclined to axis and inclined to generator, section plane is cutting inclined to axis as well as inclined to generator, sectional view then it will be hyperbola. Here section plane is cutting inclined to both axis and generator. Our sectional view will be hyperbola. So, this is the basic introduction about conic sections. So, next, construction. And we all know that eccentricity, this ellipse, parabola, hyperbola, these are defined based on the eccentricity value. If eccentricity is equal to 1, it is known as parabola. If eccentricity is less than 1, it is ellipse. Eccentricity is greater than 1, it is known as hyperbola. So in conic sections, these three curves we are going to draw. So in exam point of view, they may ask any one, either parabola or ellipse or hyperbola. They may ask any one question for 15 marks. So first we will start construction of ellipse in general method. Construction of ellipse in general method, or also known as directrix focus method. This is very important in exam point of view. This question is for 15 marks. Construction of ellipse in general method, are also known as directrix focus method. So before going to draw ellipse, first we should know the nomenclature. Nomenclature of ellipse in general method. This line is known as directrix. Draw a vertical line, that line is known as directrix, and you select any point on the line AB and name it as C. C as center, you draw a line which is perpendicular to AB and name this one as D. This CD line is known as axis. So this is directrix and this is axis, and then this point you represent as F. This F means it is focus, and V means vertex. So your ellipse will come like this in general method. This is V1 and this is V2. V1, V2 are vertexes. Vertex at this starting point, vertex at ending point. Your ellipse will start from this point and ends at this point. So directrix is fixed line and focus is fixed point, and V1 and V2 are two vertices. For ellipse, we are getting two vertices because ellipse is a closed curve. For whereas parabola and hyperbola, we will get only one vertex. So this is the nomenclature of ellipse. And eccentricity formula. E, it is represented by the letter small e. Small e is equal to Vf by Vc. So it is the ratio of Vf by Vc. What is mean by Vf is the distance from vertex to focus. Eccentricity, it is the ratio of distance between vertex to focus divided by distance between vertex to axis. So according to drawing point of view, this is the eccentricity formula. Distance from vertex to focus divided by distance from vertex to axis. So this is about nomenclature. Next, we will see one example problem. So this is the problem. Construct an ellipse with distance of the focus from the directrix as 50 mm and eccentricity is 2/3 ratio. Also draw normal and tangent to the curve at any point from 40 mm from the directrix. We all know that directrix is a fixed line, focus is the fixed point, and we know eccentricity formula. and in this problem they have given distance from directrix to focus is 50 mm. Problem, or this is solution. Given data, distance from directrix to focus is 50 mm, and eccentricity is given 2/3 ratio. What is E? E means Vf by Vc, distance from vertex to focus divided by distance from vertex to axis. This is given. So, and tangent and normal at 40 mm distance from the 40 mm distance from the directrix. We have to draw tangent and normal from the 40 mm from the directrix. Okay, without drawing tangent or normal, you won't get 15 marks. Okay. Now we will see the construction, how to construct a ellipse in general method. First, you draw a vertical line of any convenient length, and you name this line as AB. So all construction lines should be very thin. So here our aim is to draw an ellipse. So okay, only ellipse should be thick, remaining all thin lines only. So you draw a vertical line AB of any convenient length, and next you select a point on AB at any convenient point. I am selecting this here, and I am giving name as C. Next, C as center, you draw a horizontal line. This line should be perpendicular to the AB. Okay, this is C, D, and this AB is known as directrix and CD is known as axis. Next, and in that problem they have given the distance from directrix to focus is 50 mm. So the distance from C to F is 50 mm. So CF is equal to 50 mm. Okay. Next, and eccentricity also given. Eccentricity E is equal to 2/3 ratio. This means Vf divided by Vc. So Vf distance should be equal to 20 mm and Vc distance should be equal to 30 mm. So this point I am giving name as V. So the distance from V to F is 20 mm and V to C is 30 mm. This is 30 and this is 20. 30 mm and 20 mm. Okay, next V center, V as center. This one I am erasing, but you have to represent dimensions in exam. Now V center, I am drawing a vertical line and giving name this point as E. So one thing we should remember here is VF should be equal to VE. Whatever distance is there between VF, thus that distance should be equal to VE also. Or otherwise, you take a compass. With the help of compass, V as center, you measure distance from V to F and transfer this distance here. You draw an arc. Okay, it will come like this. It will come like this. Okay. The distance from V to F should be equal to V to E. Next, with the help of drafter or scale, you join C and E and extend this CE up to some extent. Okay, I am drawing CE line and extended this line up to here. And with the help of protractor, or you set your drafter at an angle of 45 degrees, F center, you draw one inclined line. This line and this CE line should interact or should meet at somewhere. At that point, you drop this point vertically downwards. Okay, and this one I am giving name, this on axis line I am giving name this one as V2, and this one I am giving name as V1, and this angle should be equal to 45 degrees. Okay, this means our ellipse starts from V1 point and ends from V2 point. Now, I am dividing V1 and F into 2 or 3 parts. This is my convenient. As per your convenient, you can divide this VF into 1 or 2 or 3 parts. For my convenient, I am dividing this into 2 parts. Okay, and I am giving this names as 1, 2, and after that I am also dividing this FV2 into number of parts. This is also our wish only. As per your convenient, you divide. They should not be equal or unequal. That is no matter. I am dividing this FV2 into number of parts like this, and I am giving names this one as 3, 4, 5, 6, 7, 8, etc. Okay. Next, with the help of compass, and also I am giving names this one as 1 dash, 2 dash, 3, 4, 5, 6, 7, 8. Next, with the help of compass, you measure the distance between 1 to 1 dash. You measure distance from 1 to 1 dash with the help of compass F center. You cut this first line and you draw arcs on both sides of the axis, and you give name this one as P1 and this one as Q1. Similarly, with the help of compass, you measure distance between 2 to 2 dash and transfer this distance here. F center, you draw arcs on both sides of the curves, and you give name this one as P2 and Q2. Similarly, measure distance from 3 to 3 dash, F as center, you draw arcs on both sides of the axis, and you give name this one as P3 and Q3. Next, 4 to 4 dash distance, F center, draw arcs on both sides. Name this one as P4, Q4. 5 to 5 dash distance, F center, draw arcs on both sides. This is P5 and this is Q5. Next, measure distance from 6 to 6 dash, F center, draw arcs on both sides of the curve. This one is P6, Q6. Similarly, 7 to 7 dash, F center, draw arcs on both sides of the curve. This is P7, Q7. Next, 8 center, measure distance from 8 to 8 dash, F center, you draw arcs on both sides of the curve. And similarly, V2 to 9 dash, you measure distance, and F2, F center, you draw arc, it will come here, it will come on V2. Okay, this one I am giving name as P8 and this one I am giving name as Q8. Now, with the help of free hand, you join first Q P1, P1 P2, P2 P3, P3 P4, P6 P7, P8, and V1 Q1, Q1 Q2, Q3 Q4 Q5, Q6 Q7 Q8, like this. It will come like this. Here my drawing is not accurate because I am not using any scale, any dimensions. If you use instruments, you will get exact dimensions, you will get very neatly. So this is the construction of ellipse in general method. Next, we have to draw tangent and normal to the curve. In this question, they have asked draw tangent and normal at 40 mm from the directrix. So, with the help of drafter, you measure the distance from directrix to curve is 40 mm. So, at this point, my distance from directrix to curve is 40 mm. You mark 40 mm. Now, with the help of drafter, you give name this one as M. Now, with the help of drafter, you join M and F, and perpendicular to this MF, you draw 90-degree angle. This should be 90-degree. So with the help of drafter, you join these 2 points. This one I am giving name as M dash. With the help of drafter, you join M dash and M, you will get tangent to the curve. And this, with this M dash line reference, you draw a perpendicular line. This is normal. This is normal. So this is the problem, general method, problem in general method, construction of ellipse in general method. Next one. Construction of parabola in general method. So before construction of parabola, first nomenclature. First draw line AB. This line is known as directrix. Now select a point on AB, give name it as C. C center, you draw a perpendicular line and you give name this line as CD, and CD is known as axis, and you select a point on CD and you give name it as F. F is the focus, and this one is vertex. Your parabola will come like this. Since parabola is a open curve, here we are having only one vertex only, whereas in parabola, whereas in ellipse we are having two vertices, since it is a closed curve, whereas for parabola we are having only one curve. So this is the nomenclature, and for parabola eccentricity value is equal to 1, E is equal to 1. E is equal to Vf by Vc. Now coming to problem, construct a parabola. Construct a parabola with the distance of focus from the directrix as 50 mm. Also draw normal and tangent to the curve at a point 40 mm from the directrix. So this is the problem. First, all steps whatever we have followed for ellipse, parabola also same. First, draw a straight line of any convenient length AB. Select a point on AB. This point as center, you draw a straight line which is perpendicular to AB and give name this line as CD. Here AB is directrix and CD is known as axis. In this problem also they have given the distance between directrix and focus is 50 mm. So C center C2F distance is 50 mm. At a 50 mm distance, you mark this point as F, and here F is focus. So distance from C to F is 50 mm, and we know that E is equal to Vf by Vc, and this should be equal to 1. For parabola, eccentricity is equal to 1. This one is V. Now V center, you draw one vertical line and you give name this one as E, and we know that Vf is equal to Ve. This distance I am transferring here. With the help of compass, I am transferring here. Okay. Next, C center with the help of scale, you join C and E and extend this line up to some distance. Next, you divide this V and F into number of parts, 1 or 2 parts you divide, and you give name this one as 1, 1 dash, 2, 2 dash, 3, 3 dash, 4, 4 dash, 5, 5 dash, like this. Next, with the help of compass, you measure distance from 1 to 1 dash, F center, you draw arcs on both sides of the axis. Next, 2 to 2 dash distance, 2 to 2 dash distance, F as center, you draw arcs on both sides of the axis. Similarly, 3 to 3 dash distance, F center, you draw arcs on both sides of the curve, on both sides of the axis. Similarly, 4 to 4 dash distance, F center, you draw arcs on both sides of the axis, like this. So 5 to 5 dash distance, F center, you draw arcs on both sides of the curve. Now you give name this one as P1, P2, P3, P4, P5, Q1, Q2, Q3, Q4, Q5. Now with the help of free hand, you join V2, P1, P2, P3, P4, P5. Similarly, V2, Q1, Q1 to Q2, Q2, Q3, Q3, Q4, Q5. So this is parabola. Now we have to draw tangent and normal to this curve at a point 40 mm from the directrix. So this one is my point. I am giving name this one as M. M2 this distance, M2 directrix distance is 40 mm. Okay. Now you join M and F with the help of scale. M to F 90 degrees, you draw a line. This is 90 degrees, and this one you give name as M dash. M dash to M, you join a line and extend this line. This is the tangent of the parabola. Next, parallel to, with line this line as a reference, M dash to M, with the help of drafter, you draw a perpendicular line. This line is the normal. So this is the construction of parabola. This one also for 15 marks. Next, our next topic is cycloids. Cycloids. In cycloids, we are having 3 curves. One is cycloid, Second one is epicycloid. Third one is hypocycloid. So cycloid is nothing but when a circle is rolling on a plane surface for one revolution. When a circle is rolling on a plane surface for one revolution without any slipping, and the locus of all points gives the cycloid. See, when a circle is rolling on a plane surface for one revolution and this points is continuously changing, and the locus of all points gives the cycloid curve. This is known as cycloid. Similarly, epicycloid means when a circle is rolling on another circle that is outside, such type of curve is known as epicycloid. And coming to hypocycloid, when the circle is rolling inside the another circle, that circle is known as, that curve is known as hypocycloid. This is the definition of cycloidal curve. Now coming to nomenclature. First we will see the construction of cycloid. So before going to construct a cycloid, first we should know the nomenclature. This is circle and this is plane surface or rectangle surface. This circle is known as rolling circle or generating circle, and this one is known as, this plane surface is known as directing surface. So circle rolls on a flat surface is known as cycloid, and circle rolls outside of another circle or any curved surface. This type of curve is known as epicycloid, and circle rolls inside of another circle. Circle rolls inside of another circle for one revolution. This type of curve is known as hypocycloid. This is outside and this is inside. That is the main difference between epicycloid and hypocycloid. So here nomenclature is same. This is rolling circle or generating circle, and this is known as directing surface or directing circle, and this is also same. Okay, this is about nomenclature. Now coming to construction of cycloid example problem. See the example problem. This is the problem. Construct a cycloid given the diameter of the generating circle as 40 mm. Draw tangent to the curve at any point on it, or draw tangent to the curve at a point on it 35 mm from the line. So this is the problem. Construct a cycloid given the diameter of the generating circle as 40 mm. Draw tangent to the curve at a point on it 35 mm from the line. This is the problem. So given data, diameter of the rolling circle or generating circle, diameter of the rolling circle or generating circle is 40 mm. Okay, and tangent is 35 mm from the tangent, and normal distance is 35 mm from the directing surface. Directing surface. So this is the problem. We have already seen the nomenclature. First we will draw the 40 mm diameter circle. So initially you draw a circle whose diameter is 40 mm, and after that divide this circle into number of equal parts. So either you divide 6 or 12. So for my convenient, I am dividing this circle into 6 equal parts. First circle is 360 degrees. 360 divided by 6 is equal to 60. 30. So I am dividing this circle into number of equal parts like this. I have divided, and I am giving name this one as 1, 2, 3, 4, 5, 6, 7, 8. Next, this point as center, this one point as center. I am drawing a horizontal line whose length should be equal to circumference of the circle, because circle is rotating on a plane horizontal surface for one revolution. So this length should be equal to circumference of the circle. So circumference of the circle is pi d, where pi is the 22/7 or 3.14 into diameter of the circle is 40 mm. So 3.14 into 40. 3.14 into 40 is equal to 125.6 mm. 125.6 mm. So this is the length of the circumference of the circle, and this length should be equal to 125.6. Okay, next, after this, after drawing a horizontal flat surface with the help of 2H pencil, you project 8 and 2 together you draw a projection line and extend this line towards right. Similarly, you draw 7 and 3, project this 7 and 3 line towards right. Similarly, you project 6 and 4 towards right. So this is the center of my circle. Once you observe here, 7, C, 3, these 3 points are coming on same line. Here 8, 2 is coming on same line. 6, 4 is coming on same line. Similarly, 5 also you project towards right. Okay, and you join all these lines like this. All these are the construction lines, and this construction line should be very thin. And next, you divide this 125.6 into 8 equal parts. Here, how many parts we have divided circle should match this flat surface division also. So here in circle we have divided this into 8 equal parts. So here also we should divide this into 8 equal parts. So using acute angle method, you divide this flat surface into 8 equal parts. This is 1, this is 2, 3, 4, 5, 6, 7 and 8. And next, with the help of scale or drafter, 2 as center, you draw a vertical line. This line should start from 2 and end from 5th projector. Similarly, with the help of drafter, you draw another vertical line. All these lines should be very thin. All these lines are construction lines. Okay, next. Okay, now let us assume that circle is rolling in this direction. Circle is rolling in clockwise direction. So when a circle is rolling from this point to this point, means the distance, the center of the circle is changes from C to C1. If the circle is moving from 1 to 2 distance, center of the circle is changes from C to C1. Similarly, circle is moving from 2 to 3 distance, center is changing from C1 to C2. Similarly, circle is moving from 3 to 4, center also changes from circle center also changes from C2 to C3. And next, circle is moving from 4 to 5, center also changes from this is C, this one sorry, the notations I am changing here because of confusion. To avoid confusion, I am changing the notations. This is P 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. This is 7 and this is 8. This is C1, C2, C3. And next, circle is moving from 3 to 4 distance, center also change C3 to C4. Next, circle is moving from C4 to 4 to 5, center is changing from C4 to C5, like this, C6, C7 and C8. Okay, the circle is moving, my circle position is starts from this point and ends at this point. Now, this is the starting point and this is ending point. Okay, now with the help of compass, we need to trace the location of point. With the help of compass, C1 as center with circle radius, you draw an arc on second line, this second line, and you give name this one as P1. Similarly, C2 as center with circle radius you draw arc on this line. C3 center you draw arc on this line. C4 center you draw arc on fourth line, and C5 center C4 center you draw arc on fourth line, and C5 center you draw arc on fifth line. It will come exactly here. This is half revolution. Similarly, C6 center you draw arc on sixth line, C7 center you draw arc on seventh line, and C8 center you draw arc on eighth line. It will come here. Now with the help of free hand you join P1, P1, P2, P2, P3, P4, P5, P6, P7, P8, and finally it will come like this. So this is the starting point of the curve. This is the starting point of the curve. This is the half revolution. And this is the complete revolution. So this is the cycloid curve. Now with the help of compass, we have located the arcs, and with the help of free hand we have joined all the curves. Next, we have to draw tangent and normal at 35 mm from the directing surface. So with the help of compass, you measure 35 mm distance, and it will come around here. You name this one as M. Next, M center you join this one, you give name this one as M dash. M dash as center you draw a vertical line, and you join this one, you give name this as N. N center join M and N and extend this line. This is the normal of the cycloid, and with the help of drafter with this line as reference you draw tangent. So this is about cycloid. And next, epicycloid. Epicycloid. This is the problem. Draw an epicycloid of a circle of 40 mm diameter which rolls on another circle of 120 mm diameter for one revolution clockwise. Draw a tangent and normal to the curve at a point 90 mm from the center of the directing circle. This is the problem. Here rolling circle diameter is given and directing circle diameter also given. Rolling circle diameter is 40 mm and directing circle directing circle diameter is 90 mm. We already discussed that epicycloid is a cycloid which rolls, this rolling circle rolls on another circle for one revolution. So, this is the starting point of the curve and this is the ending point of the curve. So, this angle we should find out. So, theta is equal to small r by capital R, where small r is the radius of the rolling circle and capital R is the radius of the directing circle. So, this is 40 mm and this is 90 mm. Theta is equal to 40 divided by 90 into 360. So, angle is theta is equal to small r by capital R into 360. Here small r is 40 mm and capital R is 90 mm into 360. This angle should be equal to 160 degrees. So, no need to draw entire directing circle, because our rolling circle is starting from this point and ending will be this point. So, we should find out this angle and draw. No need to draw all entire circle. First, construction of epicycloid. For construction of epicycloid, first you draw a circle whose diameter is 40 mm, that is given in the problem. You divide this circle into number of equal parts, or otherwise you can start like this. Okay. First you draw a line of any angle, any convenient angle. Name this one as first you draw a line, inclined line. Name this one as AO. This AO should be equal to the radius of the directing circle. What is the radius? AO is equal to 60 mm. This is the radius of directing circle. AO is equal to 60 mm. And what is angle? Theta is equal to small r by capital R into 360. Small r is 40 mm, capital R is 60 mm into 360. Forty divided by 60 into 360. Sorry. This is 120. Sorry, I'm sorry. 40 divided by 120 into 360. So, angle is 120 degrees. Angle is 120 degrees. Now, you draw a inclined line of any convenient angle. Length should be equal to radius of the circle. Now, give name this one as AO. Now, with the help of protractor AO as reference, you draw 120 degree angle and you give name this one as B. So, angle AOB should be equal to 120 degrees. Angle AOB should be equal to 120 degrees. This is 120 degrees. Now with the help of compass, you join O as center, you join A and B, you will get one arc like this. Now this is the directing surface angle. Now you extend this AO up to 40 mm, up to 40 mm. Next, with the help of compass, with 20 mm radius, you mark a point on this AO line. AO line. So this one I am giving name this one as C. C center, CA radius, you draw a circle. C center, CA radius, you draw a circle like this, and you divide this circle into 8 or 12 equal parts. This is the rolling surface, rolling circle, and this is the directing circle. So circle is rolling in this direction, clockwise direction. So I am giving name this one as, this point is P, this point is 1, 2, 3, 4, 5, 6, 7, 8 or P. Now I am also drawing construction lines. O center, O2 1 radius, you draw an arc. It will meet 1 and 7 division. Similarly, O center, O2 2 radius, you also draw an arc. It will also meet 2 and 6. O center, O2 5, it will meet 5 and 3 division. O2 4, it will come like this. Next, you divide AOB, this AB arc also, into 8 parts using trial and error method. Using trial and error method, to divide this AB into number of 8 number of parts, equal parts. This is 1, 2, 3, 4, 5, 6, 7 and 8. 1, 2, 3, 4, 5, 6, 7, 8. Next, from center also you have to draw another arc. It will also come like this. So 0 to C, if circle is moving from point P to 2, center is changing from C to C1, next C1 to C2, C2 to C3, C3 to C4, C4 to C5, C5 to C6, C6 to C7 and C7 to C8, like this. Next, with the help of compass, C1 as center, you draw arc on first curve. C2 center, you draw arc on second curve. C3 center, you draw arc on third curve. C4 to center, you draw arc on fourth curve. This is off revolution. It will come exactly here. Next, C5 as center, with the circle radius, you draw arc on fifth curve. C6 center, draw arc on sixth curve. C7 center, draw arc on seventh curve, and C8 center, draw arc on eighth curve. This is the ending point of the revolution. Now with the help of pencil and free hand, you join all these curves. It will come like this. So this is the epicycloid of the problem. Epicycloid. This is about cycloids. Now coming to next topic, projection of points, that is orthographic projections. Orthographic projections. So we all know that we are using only first angle method. We know the horizontal projection, horizontal plane, vertical plane. What is mean by horizontal plane, vertical plane? What is first angle? What is second angle? Okay, all these things we have already learned. So coming to first angle projection, this is if object is placed at first angle, then it is known as first angle projection. If object is placed in second angle, then it is known as second angle projection. If object is placed in third angle, then it is known as third angle projection, and it is known as fourth angle projection. So first angle projection is above HP, in front of VP. Second is above HP, behind VP. Third angle projection is below HP, behind VP, and fourth angle is below HP, in front of VP. This means observer is always looking the object in this direction only. Observer position is not changing, but object position is changing. So first angle projection is above HP, in front of VP. Third angle projection is below HP and behind VP. Second angle is above HP, behind VP. Fourth angle is below HP, in front of VP. So we are using only first angle and third angle. We are not using second and fourth angle projection. Coming to exam point of view, projection of points may ask for 8 marks question, and projection of lines inclined to both planes will ask for 15 marks question, and projection of planes also they may ask for 15 marks. So coming to simple problem in projection of planes, in projection of points, see this problem. Draw the projection of the following points on the same ground line, keeping the projectors 25 mm apart. So point A in the HP and 20 mm behind VP. Point B 40 mm above HP, 25 mm in front of VP. In the VP and 40 mm above HP, 25 mm below HP and 25 mm behind VP. 15 mm above HP and 50 mm behind VP. 40 mm below HP and 25 mm in front of VP. Point G is in both HP and VP. This type of questions may ask. So this is very easy problem only. We should know the point is in which coordinate before going to draw the problem. So first, for this problem, first you draw a reference line and XY. So distance between 2 points is 25 mm. That is also given in the question. So point A, coming to point A is in the HP. Point A is in the HP and 20 mm behind VP. This is in third quadrant. Point A is in third quadrant. This means your third quadrant will be like this. This is the third or second quadrant. Point A is in the HP. Point A is in the HP. And this is horizontal plane and this is vertical plane. Observer is seeing the object in this direction. Point A is in the HP and 20 mm behind VP. 20 mm behind VP. If you see the object in this direction, this projector will come here. This is my front view, and keeping the vertical plane is fixed and rotating the horizontal plane in clockwise direction, it will come here. This is top view. This is A and this is A dash. Next, point B is 40 mm. Point B is 40 mm above HP and 25 mm in front of VP. Above HP in front of VP means which quadrant it is? It is obviously first quadrant. This is first quadrant. Point B is 40 mm. This is point B is 40 mm, 40 mm above HP and 25 mm in front of VP. So this is in first quadrant. Next one, point C is in the VP and 40 mm above HP. Point C is in the VP and 40 mm above HP. This is also, it is in, point C is in either first quadrant or second quadrant. We can assume this point C is in first or second quadrant. So first I am drawing the quadrant. This is horizontal plane and this is vertical plane. Point C is in the VP. This is in the VP and 40 mm above HP. 40 mm above HP. This is point C. And coming to point D. Point D is 25 mm below HP and 25 mm behind VP. Below HP and behind VP is in third quadrant. This is third quadrant. This is XY reference line. Point D. Point D is 25 mm below HP, 25 mm behind VP. This is in third quadrant. Next, point D. Point D is 25 mm below HP, 25 mm behind VP. Below HP and behind VP is in obviously third quadrant. This is third quadrant. Next, point E, 15 mm above HP, 15 mm above HP and 50 mm behind VP. Above HP, behind VP is in second quadrant. Above HP, behind VP is in second quadrant. And last one, point G is in both HP and VP. Point G is in both HP and VP. This is the solution of the problem. For points, we have to draw first reference line. Point A is in HP and 20 mm behind VP. 20 mm behind VP means if it is in If it is in second quadrant, it will come like this: 20 mm point A. This is A and this is A dash in the HP and 20 mm behind VP. Similarly, point B is 40 mm above HP and 25 mm in front of VP. 40 mm above HP. This is point B is point B is 40 mm above HP and 25 mm in front of VP. Point C is in the VP and 40 mm above HP. Point C is in the VP. This is top view and this is front view, like this. Next, point D, 25 mm below HP, 25 mm behind VP. Point D is 25 mm below HP, 25 mm below HP, 25 mm behind VP. This is point D position. Next, point E is 15 mm above HP, 50 mm behind VP. Above, behind means it is in second quadrant. So 50 mm behind VP, 15 mm below HP. This is the solution of the problem, and point G is in both HP and VP. So this is projection of points. This type of problems they may ask in exam. Next, coming to projection of lines, these are the some of the orientations. First, I will explain projection of lines. Projection of lines. First position is line is parallel to both HP and VP. This is first position. Line is parallel to both HP and VP. Next position is line is perpendicular to HP, parallel to VP. Line is parallel to VP and perpendicular to HP. This is second position. Third position is line is parallel to HP and perpendicular to VP. Line is parallel to HP and perpendicular to VP. This is third position. And fourth position is a line is inclined to HP, parallel to VP. Line is inclined to HP and parallel to VP. Fifth position is line is inclined to VP and parallel to HP. And last position is line is inclined to both HP and VP. Total 6 positions are there. Line is inclined to both planes. So line inclined to both planes is the important topic in this chapter. So total 6 orientations are there. Out of 6, a line inclined to both planes is very important concept. So this particular problem can be solved in 3 stages. So we may get in a final end exam 15 marks question. This is 15 marks question. So a line inclined to line is parallel to both HP and VP. This is one orientation. Line is parallel to one plane, perpendicular to other plane. This is another orientation. Line is inclined to one plane, parallel to other plane. This is another orientation. Line inclined to both planes. This is very important. So this type of problem we may get in end exam. First, I will discuss one example problem in this topic. See this problem. A line AB is 75 mm long, is inclined at 45 degrees to HP, and 30 degrees to VP. Its end B is in the HP and 40 mm in front of VP. Draw the projections. So here length of the line is AB is equal to 75 mm. Next, is inclined at 45 degrees to HP. So inclination with HP is denoted by the theta, inclined to 45 degrees to HP, and inclined to VP is denoted by the letter phi. Phi is equal to 30 degrees. Phi is equal to 30 degrees. Its end B is in the HP and 40 mm in front of VP. So end B is in the HP and 45 and end B is in the HP and 40 mm in front of VP. in front of VP. So this is the given data. So here I am considering end B is in the HP. This is the line AB whose length is 75 mm. So end B is in the HP and 40 mm in front of VP, and this line is inclined at 45 degrees to HP and 30 degrees inclined to VP. Draw the projections. This is the problem. So this is 3-stage problem. First, we have to assume that length this line is which is parallel to both HP and VP. After that, you have to assume that this line is inclined to one plane and parallel to other plane, and then you need to draw. After that, you have to assume that this is inclined to one plane and parallel to other plane, and you have to draw that one, and by assembling these 3 steps you will get final stage. So first you draw a reference line. Draw reference line XY. This is vertical plane and this is horizontal plane. End B is in the HP. This one I am giving notation this one as B dash. Now B dash as center. Draw 45 degree angle of length is equal to 75. This angle is 45 degrees of length is equal to 75 mm. End B is in the HP and 40 mm in front of VP. You draw 40 mm locus line. You project B dash vertically downwards, and this point is known as B. B dash is the front view of the point and B is the top view of the point. You project this vertically downwards. Now B as center, you draw 30-degree angle. Draw a 30-degree angle. This length draw 30-degree angle of length is equal to 75. 30 degrees. Now A dash as center, you draw one locus line. A center, you draw another locus line here. Now A dash as center, you project this A dash vertically downwards on B locus line. Similarly, you give name this one as A1. This is A2. A2 center, you project this line vertically upwards on XY reference line. This one is A2 dash and this one is A1. So A2 is the top view, A2 dash is the front view, A1 is the top view, A1 dash is the front view. Now with the help of compass, B dash as center, B dash to A2 dash radius, you draw an arc. So it will intercept the locus line of A1. So this one I am giving name as A dash. Similarly, B